First, I will talk about some AI histories. So I think the history is short, but can be really useful if we know some of the background so that you know what we're doing. So let's start from very interesting story. There was a professor, his name's Cesare Cremonini. So he's a professor of natural philosophy in ancient times. And he's actually in the same era as Galileo. One day, Galileo has created this telescope right here, and he proposes to Cremonini that, hey, look through this so you can see the stars. But professor refused to do so because he has accumulated so many knowledge in the past, including that the Earth is the center. So he's afraid that once he looks through this telescope, that his whole philosophy and his whole world will collapse. So he refused to look into it. So this is actually a very interesting. It was not that famous due to his academic contribution from many people that I know, but he's certainly very famous for refusing to look through the telescope. So this is time that we should look through this lens of AI to see what it can offer and how things will change. There's a chance that, there may be no fundamental change in the world, but there's also a chance that there is a fundamental change in the world. The only way is we need to go through it and take a look what's going on. If you do not look through it, you do not know where the boundary is. Now let's take a look at what's happened in the history since 2022. That is the time AI becomes more visible. It always exists. The general concept of AI can trace back to just data analytics. So in general, anyone that can make machine to learn some patterns for you can be classified as AI. So technically speaking, least square estimation is also AI, right? But it becomes more visible in 2022, it's November. So in 2022, November, the ChatGPT moment came. It's attract 1 million users in 5 days and 100 million users in 2 months. This is probably the fastest consumer technology adoption in human history. It's faster than anything we know so far. And the factor is, it's the first time that a machine can be visibly identified at the past Turing test that is acted as a human. If you're not super careful or even you're very careful, you may not realize what is talking to you, right? You may think that a human is talking to you. It can write an essay, it can explain complex concepts, it can help us to code, it can write emails for us, it can even pass university exam. So by then the university become very panic, right? Start first action will to ban it, and then although I don't agree, but I think in the end of the day, there's different ways to test people. The old assessment method become kind of questionable, so we start to think about new ways to do it. It changes everything, and we know that. Now, on March the next year, just 4 months after, ChatGPT 4 become available. It's not just bigger, it's smarter. It passed many exams. As you can see on the right, there is a clear improve from 3.5 to 4. In the 3.5, okay, this is not bad. It's a good toy and we can play with it. When you come to GPT-4, it becomes a powerful tool that actually can surpass most of the human. This is just awesome, right? If you see this tool, you should not hesitate to use it. Now, during this early stage, right, the model is a chat model. So you type something and it gives you some output. For example, you say hi, it will say hello back or something, hi, how are you? Something like that. That's quite easy to understand, but it's already pretty awesome because it really looks like humans talking to you. Now, in this area, some people become more serious about this, okay? Because the large language model actually works like a super good prediction machine. It's able to produce a very good response, but people are thinking, can it do better, right? If I asked the right question, can it answer me more clearly? The answer is clearly yes. So there's some new techniques coming to being. The names sound fancy, but actually if you can translate to human words, it's quite straightforward. One is called few-shot prompting or just few-shot learning. That is, you just give it some examples. If you give the model some examples, the answer will look nicer. Another one is called the chain of thought. You just explicit ask the model to think step by step. Another one is role assignment. You say, hey, you're an expert in some particular area. And you can also ask to give a particular format as the output. Now here's a typical prompt in 2023. Your senior data scientist analyzes data set, identify top 3 predictors of customer churn, think step by step, format output as a table. So this is some easy prompt engineer. I think we probably all should know about this, right? Before you type to your AI, you should him to do a role play and give some background information that's supposed to give you a better result. The limitation is, so every interaction is going to be a single turn. There's no memory, there's no tool, and there's no persistence. If you change to a different thread of the conversation, then you probably forget who you are. Now, a year after, and there's still a lot of race, big firms focusing on create better models. Usually we refer those models as the brain or AI brain. It thinks, it doesn't work, but it can think a lot. So the brains are OpenAI's models, Anthropic models, and Google's models, and Meta's models. Meta's model is kind of lag behind these days, but in the early stage, they can still fight. And there's a rising ecosystem around the world. In Europe has Mistral. I'm not sure how many people are still using it, but still Europe's signature flag there. And Elon Musk xAI have a Grok model. And in the meanwhile, China has this war of 100 models existing. So there are many firms put lots of money in it and try to create some useful things for future. So for AI agent, it's become a new thing. Even for recently, people keep talking about it. As long as people keep talking about it, it's still going on. But this concept starts pretty early. The motivation is that people like, hey, chat is great. Okay, I like to chat, so I learn a lot of knowledge. But because we're human, we're lazy, we ask, can you just, in addition to chat and teach me, can you just do it for me? So we think about, hey, instead of a chatbot, can you do a coding buddy? Can you do the work for me directly? The reason we start coding buddy is just because programs are the first batch of people who are using it and able to change the working paradigm. They're just capable. They're so capable such that they're going to dig their own tomb in the future, right? 2022, you say, write me a function. Until now, you say, hey, help me to build this, and that. Okay, so this is kind of a mental milestone such that people moving this AI from thinking to doing. So let's talk about this a little bit more detail, okay? The challenge is the context. If you think about if you're a boss, right? You have an employee and you say, just build me a wonderful architect. He has no idea what you're thinking, right? He doesn't know what this architect for. Is it a museum? Is it a library? Or is it some residence building or business building? Or how many people do you need? What's your budget? And so on and so forth. Right? You cannot just use one sentence to finish everything. So just this is not well-wash, not a well-wishing. So simple prompting is not good. So you need to provide a big document to your computer or to your model so that the model can understand you better. Right? So there's context dependencies. There's a copy-paste limitation that we all need to take care of. Right? Context dependency is if you wanted to do some tasks, you need to tell what's going on here. What's the data? What's the guideline, right? How to build and what's your expectation? What's the algorithm if you do data analysis? And there's also copy-paste limit in the sense that the context window is limited, right? The model is big. It cannot handle, even so big, it cannot handle unlimited text. right? So it just lose memory or cannot compute due to the large context window. So instead of just tucking everything and in a simple but brutal prompt, your prompt is able to be billions, but the model cannot handle it. So you need to think smartly how to do the job. So we ask, can I write a better prompt such that you only use it when you need it in a particular part, just like human. If you know you're going to do a project, for instance, maybe today you just focus on analyze the data. And for this particular hour, you only look at this small particular data set, or even just only look at the data description to get some idea. So this is the context window mean, right? If you focus on particular task, you only need a small number of these context items instead of putting everything inside. So this is context engineers motivation. Okay. So for typical contexts that we're using, for example, in anti-gravity, so what we're going to feed into this brain in the middle include several components, right? First, you give it a general rule. That is more like the governing law of this whole project, right? Tell him this is what project, where the key folders are, and what code do we use, and do we have additional resources? Can we link to the online server for computation, etc.? There's also called MCP servers. That's an additional tool that the model can use, right? This is works as a models package. If you use Python, you know there are many different packages that the basic Python can call for. This MCP just like language models package, right? It can use different software based on the server. The server works like a systematic menu for you to use some particular software, such as MATLAB, Stata, etc. And then you can customize your own workflow and create skill files. And those skill files work as your local package. Think about if you use a Python, in addition to using packages, you can also use this, create your own function. It's small, but it's flexible. So you can use both function and packages just for your own purposes. And if you use an IDE in doing your work, a smart agent can also tell where your cursor is so that it know which are you focusing on, so it can build the answer based on where you are. And it can also see which files you're opened to create a local context for your local project. So this is just as, hey, I'm doing this project. Now I'm in the least square, running least square by this small subset. So it can focus. So the context will be smaller and useful, and all the other currently irrelevant material will not be discussed. So the model will work better. It also have the whole long chat history, just in case you want to trace back. And it also have access to your local files. It's called local code base, but this is computing science people's terminology. For us, just folders. It also knows which operating system you're using, which path you're at, so it's able to use correct tool call set to make executions. If you're in Windows, the command that to copy files or the command to read files could be slightly different if you use Linux or MacBook. So this system information will also be fed to the brain. So altogether, they come to the brain and the brain will process it and send information back and start executing. So this is the context ecosystem. Okay. So we have already lots of context-only tools. So there's a Cody, there's Google Notebook LM and ChatGPT projects, and there's also Copilot Chat. And projects currently can still do some execution now, so it's not a read-only, but everything here, let's say ChatGPT projects, you upload files there, it can do something for you. So basically, they have the files all compiled around them, and they're going to learn about it, and they're going to use their systematic ways to organize the context and feed to the brain. And honestly, if you're not a developer for those particular apps, you really do not know what they feed exactly to the brain. You have some idea, you know approximately what is fed to the brain, but you do not know exactly what they do. There's algorithm behind it. Whenever there's a new research paper came out, adapt and evolves. But the overall framework is just like that. And actually need to know exactly what they're going to feed into them. The reason is LLM itself is flexible. It's not a hard coder. LLM is soft. It's a brain working like a human. It understands small difference won't make too much change to the output. That's the beauty of it, right? We don't have to remember things. We just give some proper information to the brain, and brain will give us some proper output as ideally. That's what we want. Okay. So these are the apps that use context and some feedback. But in addition, right, so it is a safe because even for ChatGPT project, you upload it to the cloud. Even it make anything changes, it won't affect your local machine. So your environment, your local files are very, very safe. So it only read. Okay. But in addition, right, you do not actually want it to read only, right? Motivation to let agent to work. So contact is great. It can give agent more information so it sees more. But a real agent also need to have hands so that it can do. So we have this kind of harness engineering concept come into being. So we have contacts that help you to sense and see. We have harness so you can do and control. So together we can build an agent. That is what they call this agent. The magic, there's actually no magic. So you have an agent that is represented by an app. For example, anti-gravity, that is an agent. Okay, so what does it do? You have a command. So the model start to make a plan. You have a command, the agent ensemble your information and give it to the brain right away. And the brain think about it and then come back with output to say, hey, this is what you need to do step by step. And the agent look at the first step and start collect additional information that brain need and send it to the brain. And so on and so forth. And the brain sometimes ask you, hey, execute something. So the agent will do some execution. And when the output came out, the agent will copy the output, feedback to the brain, and brain judge. Is it successful? If it's successful, maybe proceed to the next stage until the end. If it's unsuccessful, okay, I'll just do some debugging and send a new command back, and this agent and brain will iterate until the task is done. So this is how the agent is working. Okay, you have a center of the brain that take information in and send information out. And the agent itself is responsible to get the instruction and execute and then copy the result back to the brain. So this kind of interaction help us to get the work done. Okay. How the text become action? Let's take a look at the example. Okay. So for example, we signed the model. Hey, I want to do something. And the model think about it, and the model send back information to us. Look, the brain only give us back text. Okay. Let's ignore the multimodality. Even multimodality is just come back with images and voices. It doesn't come back with something directly executed. Okay. So the agent come back and say, hey, I will run the project test, and this is a marked language. So mark means, hey, there's a tag. It's the beginning of the call, slash of the call, and there's some command inside. So far, they're all text. If you can type it, it's text. You can type bracket, call, column, run, and then this is what you see. Actually, this is what agent see. Now, the agent is a special software, right? The agent will scan the language You probably don't even see this. This will just send it to the agent. Agent receive a file, a text file, and say, oh, I can see. I'm going to scan it. When the agent scan and see this one, he say, oh, this is a function that I need to run. Okay, so they detect the tag. This is a tag. This is hard coded, so the agent can easily find it. So they find it, a tag. Now it say, oh, stop. Okay, stop. The model, the language model asks me to stop here and run this. So he found the tag, find the end of tag, copy this, and put it in the terminal or some other places just to let it run. Okay. If without this step, if it's just human, you talk to ChatGPT online and it gives you, oh, I will do this, what would you do? You do the same thing. Actually, you use your eyes to scan this and you find, oh, maybe I should just copy this and paste on my computer and let it run. So the agent just do the copy and paste for us. Okay, this is nothing mysterious. Agent do the copy and paste for us. And then agent put it in the terminal and run this, and this is the result. Or you can just skip step 2 before and you copy and paste and you get the same thing. Okay. And if you do this yourself, you see the test successfully, maybe you stop. Okay. But the agent actually does not know. The agent is the local app on your computer. What agent do is just copy this part and give it back to brain. The brain see this, say, oh, this is successful. Then the brain send back notice, say, hey, this is done. Okay, now you can print on the screen to tell your user that this is finished. So this is a very basic, even naive example how agent work, but this is actually how the agent works, right? The agent has more fancier stuff, but this is the principle how they do. They send information to the brain and the brain send information back, and then you look at that again, back and forth. If there's error, there's a back and forth. If successful, it is done. The agent is in charge of scanning and copy and paste and click enter to execute it. Harness is a good infrastructure. It's able to do things for you, but it also have some guardrail such that if you do something really bad, destructive, some brains or get injection tested, harness actually can stop it because brain can be messed up. Okay, so the brain can have injection attack and the other type of attack as well, but the harness will not, because harness is a hard-coded program. If the harness see destructive command and is hard-coded in the harness, it will stop. So this is a one-way protection. But in anti-gravity, there's another layer of protection that's called sandbox. So you actually work in isolated areas, so it cannot go outside of sandbox. That's even better. So usually the coding agent is well protected. We don't have to worry about that. Unless when the brain, if the brain is poisoned, for example, it give you a destructive command, but the agent stop it, but the agent need to confirm with you. The agent say, this is dangerous. Do you want to proceed? There's confirm or cancel. And you do not understand the command and you process confirm, then that is your problem, not the agent problem. Okay. So this is about how the agent do. Now, remember always, human are lazy. So we're thinking about, okay, so we need to do many works to feed the context and stuff and so on and so forth. Can I not feed so many contexts? Can I just start some job to say, hey, I want to do this. I want to build this beautiful architecture. I still want to do that. I want to use my mouse to finish something. Okay. And do not want to provide context directly, but you can ask me, right? As a proactive employee, you can ask me, hey, what kind of architecture? Then I can answer you with very short words and so on and so forth. When you think it's enough, you just go ahead. This is kind of autonomous AI agent. So that's what we want to do. So we want AI to do the task by themselves, and the human only do a minimum amount of job, as small as possible. So that's the idea. So AutoGPT is a pilot app that to do those things. Okay. it's able to break subtasks, it execute autonomously, and you only need to give a higher level goal and let it do so it can explore the internet, write files, call APS, so on and so forth. This is a pilot run. And usually the pioneer died, and then there will be better things come out. But this is a remarkable time to mark that this autonomy AI agent become the dream of human, and that is why there are so many different things these days that you can use. Okay, for example, everybody knows OpenClaw. There's also Hermes. Those are the very useful autonomous agent. But autonomous agent can be destructive because they just do whatever they want, okay? And you really cannot have 100% control because they're so fast. There must be something we overlook. It's just like in the movie. You need to pay attention to what you wish for. And that is why Mac Mini become more popular. People just buy a Mac Mini and save your agent there and let it just, hey, play with this house. You're physically confined, so you cannot really do on my regular computer. Now let's take a look at the chronology of AI coding agent, right? They called AI coding agent because the computer scientists, they create this, they use it to code. And another reason is that coding is verifiable, okay? So the code, if it can run, it can run. If it cannot run, it cannot run. So there's a clear 100 dichotomy here. So that's why the model can easily be trained. But for arts or data analysis, it's not that easy because our project usually is unknown, right? So there are some routines, but we know each project should have its own features and different. We don't know, not exactly know which one is the best way, but this is the beauty part of it, right? So let's go back to this AI agent or AI bracket coding agent. We start from 2021. So there's a GitHub Copilot that use AI and to help to generate code. And in early 2023, that is after GPT come into being, there's a Cursor, there's Aider. They use context engineering and able to do the coding for programmers. And 2024, there's Devin, that's first commercial autonomous agent. There's a sandbox coming and it can help to plan your job. 2024 late, there's a Windsurf. Now they first introduced the idea of AI flows. It's pioneering. So there's implicit harness coordination. Now it become more people adopt to it, but usually it's still confined to hardcore professional programmers there. And in late 2024, again, there's a Kilo code can be easily used in Visual Studio Code. And its beauty of these two is that it's kind of this bring your own key tool, such that you can use many models, just try them out to see which one you like. So let's say agent is like a robot or something, right? So it has eyes, it has hands that can help us do things. But the brain, you can change the brain. So this is the beauty of this agent that you can change them if you like. Now 2025 in February, have a Claude Code. It's by far the most powerful coding agent that you can imagine, okay? Even now. Okay, but let's come back to our own task, right? We're not a rocket scientist. So usually the coding agent that we're talking about here is you want to make a big industrial leveled software or app so people can use it. Okay. But our task usually is to do data analysis, build a website, do some simple tasks. So this Claude Code is not designed for that. Sometimes it's even worse than that. For example, if your task is to do web search, information collections, and it's just not as good. The reason Claude Code is good at coding is because it discards many other abilities. So that is why Claude Code is very good at code. For general purpose usage, Gemini or regular GPT, so they're just good at many things, not only in coding. So that's actually why Codex become GPT recommend Codex if you do the coding, right? And there are other dedicated coding models so that it will be good at that. But if you promote a brain to be specialized in a particular area, then the other area it will sacrifice. This is always like a human. If someone's good at something, he's become a specialist on this, he may forget how to cook. So that is the idea. And in late 2025, you see the anti-gravity. That's the one that we're using. This is kind of the SOTA model. It has many interesting advantages, and it's very easy to use. Google is a strategic partnership with Anthropic. So in anti-gravity, you can also use Anthropic's model. So that is pretty decent. Now, those are the agent, that's robot we talk about, right? So now let's look at the brains. Some milestone brains is a Claude in 2024, right? This is very, very powerful improvement. And in 2025, you see the DeepSeek R1. This is the first open source model that's almost competitive as state-of-the-art closed source model, and is introduced this explicit chain of thought. This inference model become very, very useful. And actually it helps to lower the costs. And then 2025, this is a Claude Code. And 2026, you see the Claude Fable and the Mesos 5. And this is a good model, but we probably don't need this that much. It's also very expensive. Okay. Now, let's talk about the further evolution over the past year. So we start from prompt engineer, and then it evolves to context and harness engineer. And middle of this year, actually just last month, there's a new concept. It's called loop engineering. It's useful and easy to understand. When you start a task, just keep doing it, because over the time, context changes, right? For example, this is some certain economy. Next year, the economy change, environment change. You need to have a new policy. This is the idea of the loop. So keep monitor, keep doing, and somehow you probably can see this as conspiracy from NVIDIA. They just want people to burn more tokens. For us, is it that helpful? Maybe if you wanted to keep some certain jobs keep running, as long as you can have the revenue to cover the cost, why not, right? But a simple loop engineering is very easy. Loop, we all know loop, right? Just a for loop with some if judgment there, right? For example, I build a robot that's loop over time, that every month, every week you check the seminars and send out email notification. That's also loop engineering. So it's not that mysterious. Okay, loop, let's do this again and again and again and again over time. And even without end, because time change, environment change, your prompt should be changing, and you probably have some associate hard coding also need to change. Just don't stop. Okay. So loop engineering has a few features, and those features actually are not new, it's old. So you need a trigger. For example, you can ask it to test. As an economist, you test economy for when there's a huge change of stock market, or when there's a change of the presidency of a certain country, political reasons, they can all become a trigger. And there's a prompting. You need to give the agent some prompt. And this prompt is at a higher level, right? It's a prompt such that your agent should be able to make a prompt. Let's say it's a prompt of the prompt. Just stand at a higher level. And this is a highly brain related. So if you just let a small weak model to do this, your task, most likely your task will become a disaster. So you have to do a good model, pay a high cost, and loop over it. So this loop engineering is really a new concept, and it's really luxurious. Not everybody can afford it. This is also not new. Orchestration is just you, instead of having one agent, you have multiple agents to do things. Right? This is good for context. Imagine one agent to do everything. He need to remember everything. But if you have multiple agents, you have an orchestrator that take care of the global view, and every agent only need to report a result to the manager. And the manager only have the result. He doesn't need to know which particular employee has been done over the past months. He only need to know this is done. Then he tick the box and proceed. You also need a judge, like a critique. When your job is done, you need an independent critique to see if this is okay or not. There's just a few components here. So the era in prompt engineering, the early stage, like about 4 years ago, is about single response. And context and harness engineering together create this coding agent. Now, the most reason is really, really new, the loop engineering to say, hey, this is a task driven. Once the task is set up, it should keep working without stopping. Okay, but it's nothing mysterious. You just set the loop, you set up a forever goal, and then it just keep doing. The reason we can think about this loop engineering today is because the model become more capable. A great model has the ability to self-correct. If you use a weak model, your loop will be a disaster. So method usually match the ability. You can see the prompt until context, harness, and loop they keep growing because the brain become more and more stronger, right? If you use a weak brain, probably just still stop at prompt engineering. So it's more like when you have more muscle, you can carry more weights. Okay. Now let's look at the human element. Okay. As I mentioned, the code can be tested. That is why this coding agent become popular because it's easy to train the model. The model know what is right, what is wrong, but research is not. There's something related to taste, there's something related to storytelling, about how to communicate with human. We don't know whether in the future AI will have a taste, but at least for the moment, there's still a gap between human and the AI. So code generation is good, but academic research, because you need personal judgment. Trust me, it needs a lot of personal judgment in order to understand this. Okay. So some data show that 80% of developers use AI, but approximately only half just check this AI output very carefully. Again, this is due to that humans are lazy. Okay. Humans are lazy, so we create this prompt engineering, AI coding agent, loop engineering, so that we want to free our hands. In the meantime, because human lazy, we need to restrict, try to fight this temptation that's okay, let AI do everything, I will stand alone. But if you do that, your brain becomes smooth, in other words, retarded. So we don't want that, right? After all, you want AI to be your agent and you do not want to be your AI's agent. Otherwise, it's just sad. Okay. So the valuable skill is when to trust it. Okay, so still hard work is needed. For example, hallucination. In the past, hallucination is explicit, very easy to tell. Nowadays, hallucination is implicit. So that's the issue, okay? If you just blindly trust AI, then yeah, one day you might be questioned by another human and you say something stupid and then your reputation is ruined. In that case, you probably want to keep your reputation and do some work. Okay. So now this is how I understand this as quick wrap up, right? So prompt engineering is a single turn, it's a manual prompt, and tell AI to say something to you. Okay. And context plus harness engineering after just 2 years around 2024, 2025 become popular because the brain becomes more powerful, is able to do something for you in addition to tell you something. Right? Previously, you said, give me some answer. Now you can say, do the file for me and create a PDF and stuff. And most recent, you give a target. In anti-gravity, actually I already imbued this goal function. That's you slash, put the goal, tell him what you want to do, and use this skill called grill me and to ask for alignment. So you ask your questions and then you set up and it can run your task for a relatively longer time. So this is how this have been developing recently, in the past few years. Okay. So this is how I try to use some simple sentences to make you understand what has happened in the past 4 years. Okay. Sutton has a very interesting terminology. It's called bitter lesson. That is say, for engineers and smart computing scientists, no matter how good you design things, when the brutal force came into being, namely AI, your effort will eventually disappear because the big model is so big such that it will definitely be better than any human in the world. So that is the called bitter lesson. Okay, so massive computation can overwhelm our smart efforts. But this is actually belong to the computing science domain. But for us, we're the applicants, right? We don't use them. So it's for us, it's a sweet lesson. If you want some function to come and you're not in a hurry, the best strategy is just to wait. It will come for you. Okay. Now we have looked through the telescope, right? We're better than Carbonini at this moment, and hopefully the best way to understand is to use it. And I expect you guys to use it a lot in this subject so you understand where the boundary is and notice that the boundaries keep moving. So we better keep up with it. Okay. So this is the video about the history of AI and related coding agent.